Welcome to Section 5 of the Backend Web Development Using Go video course, part of the Web Programming with Go series. In the previous two sections, we learned how our users can submit data to our application by filling out web forms. Now, it's important for us to understand how we can store user-submitted data so that we can make use of that data. For example, in Section 3, we created a sign-up form, but in order for us to implement user login functionality, we need to know how to store and access the data that the user submitted. This section will focus on showing you how to store and retrieve data using a data store in Go. In this section, we will introduce you to MySQL. We will show you how to implement a MySQL data store in Go. We will then introduce you to MongoDB, and then we'll show you how to implement a MongoDB data store in Go. And finally, we'll introduce you to Redis, and we will also show you how to implement a Redis data store in Go. In this video, we will introduce you to the MySQL database. We will provide you with an introduction to MySQL. We will show you how to run MySQL using Docker. And we will show you how to create a MySQL database and import a database schema to it. We will be using Docker to install MySQL. Docker is a popular software container platform. Docker is used to package an application and its dependencies into a virtual container. Docker allows us to run multiple virtual containers on the same system. A Docker base image is a read-only template with instructions for creating a Docker container. A Docker container is a runnable instance of a Docker image. We will be using a pre-built Docker image for MySQL and the other databases that we go over in this section. Using Docker saves us a lot of time and effort from having to install and configure a custom MySQL instance on our system. With Docker, we can use a MySQL instance that's already pre-configured for us. You can download Docker from the Docker website. Refer to the Docker command line reference to learn more about using Docker from the command line. We will further explore Docker in the last video course of the Web Programming with Go series. MySQL is a popular open-source relational database. We can use MySQL to store and retrieve data. MySQL can run multiple databases in the same server instance, and the MySQL server can provide multi-user access to these databases. MySQL is a relational database. It stores data in separate tables rather than putting all the data into one big store. This adds consistency to the type of data that is being stored. In MySQL, data is stored in the form of tables. A table stands for a type of data that we want to store. Columns stand for the individual attributes of the type of data. A record is a row within the table. For example, for this user table that I have here, I have columns first name, last name, and email address. And rows would be individual records of users within the table. MySQL implements the structured query language, also known as SQL. We define and manipulate data in the MySQL database using SQL statements that end in a semicolon. There are four primary types of SQL statements. The select statement is used to retrieve data. The insert statement inserts data to the database. The update statement updates existing data in the database. and the delete statement deletes data from the database. SQL is both a DDL and a DML. By DDL, we mean Data Definition Language. These are statements that are used to define the database structure or schema. And DML stands for Data Manipulation Language. These are statements that are used for managing data within schema objects. You can learn more about how to use MySQL from the documentation section of the MySQL website. So now, we're going to run a Docker container using a MySQL base image from Docker. This is the web page for the MySQL base image. We obtain the MySQL Docker image by issuing the following command: docker pull MySQL. Now that we've pulled the Docker image, we issue the following command to run a Docker container named gopherface MySQL. So we run docker space run space -p 3306:3306 space --name space gopherface MySQL space -e space in all capital MySQL _ root _ password is equal to gopherface space -d space MySQL. We are providing a database admin password of gopherface. The -p command line option indicates which port we want MySQL to run on in the Docker container. Additionally, it's also the port we will open up on our computer to expose the MySQL service running in the Docker container. The name command line flag is used to name the Docker container. The -e flag allows us to set an environment variable within the container for the MySQL root password, and the -d flag tells us to detach, which means to run the container in the background. We can see if our Docker container is running by issuing a docker ps command. Our Docker container is currently running the MySQL server. Now it's time for us to create a new database, and for that, we'll be using the MySQL client. Let's start up a new Docker instance that connects to the MySQL server. So I've typed in this command, which will run the MySQL client. If we run docker ps again, notice that we have two containers running now, one for the MySQL server and the other for the MySQL client. Take a note of the container name the MySQL client is running under. We will be using this later. Now that we have the MySQL client open, let's issue some DDL statements. Remember, DDL means Database Definition Language. We're going to start off by creating a new MySQL database user called gopherface using the create user statement. So now I'm going to type create user gopherface at % identified by gopherface, and do take note of the single quotes. Next, we are going to create a new MySQL database called gopherface-db. So here I'm going to enter create database if not exists, gopherface-db, default character set of UTF-8, collate UTF-8 Unicode CI. Now we are going to issue privileges to the gopherface-db to the gopherface user using a grant command. So now we type grant all privileges on gopherface-db to gopherface at %. And we flush the privileges so our changes to the privileges will take effect immediately. So now we just type flush privileges. We've created a SQL script that specifies our database table structure. Let's open up the gopherface-db.sql source file in the gopherface-db/config directory. The first thing we do in the database schema file is specify the preferences we want to set. We specify that we want to use the UTF-8 character set for the client's interaction with the database server. We set the time zone to Pacific Standard Time since our server is based in Los Angeles. This time specification is relative to GMT. We set the default character set to be UTF-8. And right below that, we have this drop database if exists statement. This tells MySQL to drop the database called GopherFaceDB if it already exists. You might be wondering why we need to do this. When we develop a new database schema early on in a project, there's many things that we might change. We might decide to change the structure of tables or add new tables. So this statement allows us to rerun the SQL script multiple times to our heart's desire while we are designing the database structure. Right after that, we have the create database statement, where we have specified the character set and collate values. Each database has a character set and a database collation. A database collation is a set of rules for comparing characters in a character set. Right after our create database statement, we issue the use statement to tell MySQL that the current database we are using is GopherFaceDB. And finally, we have our create table statement. Our database at the current time is pretty simple. It contains a single table called user, and here we have defined all the columns for our table. So starting off, we have an auto-incrementing ID, which will serve as the primary key in the database. We have a username column to keep track of the username. And we have a UUID column to keep track of the account's universal UID value. And we have a first and last name column defined here. Following that, we have our password hash column, which is a SHA-256 hash of the password. It's always a good practice to store password hashes and not the explicit value of passwords in a database, since you don't want yourself or your coworkers to invade the privacy of users by knowing their passwords. We have a column here for email defined right below that. And we have timestamps to keep track of when a record was created and when it was last updated. Finally, we have a unique constraint on the username field, which enforces consistency in the structure of our database. So each record will have a unique username associated with it. Finally, we have indicated that the primary key for the table is the ID. Now, we are going to issue the docker cp command to copy the file from our system to our Docker container that's running the MySQL client. Going back to the MySQL client, we issue the source command to execute the database script and create our user table in the GopherFaceDB database. Now let's run a describe table command. Type desc space user, and now we can see the structure of the user table defined in the GopherFaceDB database. In this video, we introduced you to the MySQL relational database. We showed you how to install MySQL using Docker, and we showed you how to import a database schema for storing user account information to a MySQL database. In the next video, we will show you how to implement a MySQL Datastore using Go and store the data from the sign-up form that we made in Section 3 to the MySQL database.